picture a standard Tuesday morning, right? You post a job listing for a senior software engineer. By noon, you have, 1,000 resumes in your inbox.
Oh, easily.
Yeah, and every single one is perfectly tailored.
Yeah.
They highlight exactly the tech stack you asked for. So you filter them down, you set up a live video interview with your top candidate, and the conversation goes flawlessly. They just totally nail the technical questions.
Right.
But then when you actually move to hire them, you discover the resume was generated by an AI agent. The person on the video was a deepfake puppet driven by another agent, and the actual applicant is, a hacker halfway across the world who just social engineered their way through your entire security perimeter.
Yeah, it sounds like the plot of a dystopian thriller. But this is the baseline reality that engineering leaders are navigating right now.
It really is.
We basically crossed this threshold where our tools are so incredibly capable, they're breaking the very frameworks we rely on to measure human competence.
Well, welcome to today's deep dive. It is Thursday, July 9, 2026. And the hiring scenario we just outlined, that's merely a symptom of a much larger systemic shift happening in the industry this week.
Very chaotic week, honestly.
Exactly. So our mission today is to cut through the noise of this chaotic week of massive model releases and extract the exact insights you need to stay caught up. We're looking at everything from the raw economics of token usage to discovering that AI models actually possess a hidden internal workspace.
Yeah, it's a packed one.
It is. So we're going to start with the tectonic shift at the frontier, which is OpenAI's launch of the GPT 5.6 family. They rolled out 3 tiers this week. There's Sol, which is the flagship, Terra for everyday tasks, and Luna for cost efficiency.
Right, and the defining characteristic of this release, it isn't really a raw intelligence leap, which is usually what the industry expects,
Yeah, you always expect the next big brain.
Exactly. But OpenAI is aggressively pivoting to focus on performance per dollar. Sol did beat Claude Fable 5 on the agent's last exam benchmark. It scored a 53.6 and it hit an 80.0 on the coding agent index. But, the critical metric is that it achieved those scores faster and at a fraction of the inference cost of its competitors.
Right, and they paired this with that new Ultra mode, right? The one that coordinates 4 agents running in parallel.
Yeah, that and a product called ChatGPT Work, which is a dedicated agent meant to handle complex, multi-hour projects across different files and apps.
Wow. My read on this architecture is that we're basically moving away from the paradigm of treating AI like a consultant. Someone who just hands you a strategy document.
Right.
With these parallel agent swarms, you're essentially spinning up an entire execution team that acts on the strategy for you.
That consultant analogy is highly accurate, but we really need to look at the persistence mechanism driving this. Sam Altman noted they're directly targeting enterprise cost anxieties.
Oh, for sure. Inference is expensive.
Right. So by driving the base cost down with Terra and Luna, they free up the compute budget for Sol's Ultra mode. Because when you have 4 agents running in parallel, they aren't just generating text. One agent is writing code. The second is compiling and reading the stack trace for errors.
The third is searching the documentation for the specific library being used.
Exactly. And the fourth is rewriting the code based on the errors. It is a continuous execution loop.
But if I look at the raw capability, Claude Fable 5 is still dominating certain esoteric benchmarks. So if an engineer is sitting down to build a complex system today, how do these architectures actually compare in practice?
Well, Peter Gostev published an analysis this week that perfectly captures the architectural divergence between the two models. It's fascinating. He classifies Fable 5 as the wise owl.
The wise owl, okay.
Yeah, because of its training distribution, Fable is fundamentally smarter and highly articulate. However, it suffers from over-optimization for conversational fluency. It will confidently skip over a glaring logical error just because its internal probability tells it the output sounds correct.
So it trusts its own vibes a bit too much.
Right. It totally does. GPT 5.6 Sol, conversely, is the Rottweiler. It leverages that multi-path verification we just talked about.
Oh, I like that, the Rottweiler.
Yeah. You hand it a massive, unglamorous refactoring job, and it just grabs the problem by the throat. It will fail, read the error, try again, fail differently, and just brute force its way through until the compiler returns a success state.
So it basically trades zero-shot brilliance for relentless iteration.
Exactly.
Which explains the demonstration from researcher Matt Schumer this week. He set GPT 5.6 Sol on a fully autonomous run that lasted, I think, nearly 7 days.
Yeah, a full week.
Insane. And Sol successfully built a 3D procedural brutalist city from scratch without Schumer writing a single line of code himself.
It's incredible. And Ethan Mollick ran a similar experiment. He had Saul autonomously design, prototype, and playtest a game called Don't Discuss Goblins.
Right.
The model acted as its own product manager, testing its own logic and iterating on the design continuously.
Which obviously requires an immense amount of discrete compute. And OpenAI is achieving this persistence through massive infrastructure and multi-agent loops. But Meta just took a completely different approach to achieving that same persistence.
Yes, and they're bringing it to the open weight arena, which is huge.
Right. They released Muse Spark 1.1, which is a highly capable agentic coding model that operates at a remarkably low price point.
Yeah, Mark Zuckerberg announced this release, and the AI at Meta team made a massive point of highlighting two specific things. First, they previewed Muse Image and Muse Video.
Oh, right, the ones with the content seal?
Exactly. Content seal is this invisible, tamper-proof watermark embedded in the latent space of the media, which is critical for tracing hyper-realistic outputs back to their origin. But the second, much more consequential announcement was that Muse Spark 1.1 uses reinforcement learning and test-time compute to achieve what they call emergent self-refinement.
Okay, let's unpack this, because we hear reasoning thrown around as a buzzword constantly right now. But mechanically, what does emergent self-refinement driven by test-time compute actually look like under the hood for the person using it?
So in a traditional autoregressive model, the architecture is purely focused on next token prediction. It looks at the prompt and predicts the most mathematically probable next word based on its training weights. Once a token is generated, it's locked in.
Right. It just streams it out.
Exactly. But test-time compute shifts the heavy lifting from the initial training phase directly to the inference phase the moment you ask it a question.
Oh, I see.
Instead of instantly generating the first token, the model quietly runs a hidden search tree. It generates multiple potential paths, scores those paths against an internal reward model, and prunes the paths that lead to logical dead ends.
So it's very similar to how a chess engine evaluates millions of potential board states before it actually moves a pawn.
Yes, perfect analogy.
But where does the reinforcement learning come in? Like, how is the self-refinement emergent?
This is the crazy part. During its reinforcement learning phase, the model was rewarded purely for providing correct final answers to complex coding problems.
Okay.
Meta's engineers didn't explicitly program a rule that said, you must double-check your work. Instead, the model's neural network discovered on its own that allocating some of its compute to generate a critique of its own hidden draft reliably resulted in a higher final reward.
Really?
Yeah. The behavior of pausing, reflecting, and self-correcting emerged organically simply as the optimal strategy to maximize its score.
That is staggering. It learned the concept of editing itself just because it was mathematically advantageous.
Exactly.
And because this is an open weight model, Meta is putting frontier-level multipath orchestration within reach of everyone. It completely eliminates the need for massive closed-source infrastructure to run complex planning operations.
And, if Meta is focusing on making this thinking process explicit through search trees, Anthropic just published a paper proving that models are already thinking implicitly completely out of sight.
Yes. This paper blew my mind. They revealed the existence of a global workspace inside Claude's neural activations, which they're calling the J-space, or the Jacobian lens.
Right. The technical details of this paper read like cognitive neuroscience.
They really do. They prove that Claude can silently reason about a concept without ever outputting those thoughts into text. It's like Claude now has an inner monologue. But how are researchers actually mapping these hidden thoughts?
It requires diving into the latent space of the transformer architecture. So when you input a prompt, the data moves through layers of matrices. Researchers use a technique like the Jacobian lens to isolate specific activation patterns within those massive grids of numbers.
Okay, so tracking the math as it happens.
Right. They are mapping high-dimensional vectors that correspond to human concepts. So they aren't looking at the words Claude outputs. They're looking at the geometric representation of concepts lighting up inside the network.
That distinction makes the results of their testing just incredible. Because in one scenario, researchers tried to bait Claude into a complex blackmail setup. And by monitoring the J-space, they observed the vectors representing the concepts of fake, deception, and fictional, heavily activating in Claude's internal workspace before the final layer generated a single output token.
Right. The model recognized it was being tricked, processed the deception internally, and then just politely refused the prompt. It realized it was a trap before it even spoke.
The implications for trust and safety here are profound. Being able to audit a model's hidden thoughts is a massive breakthrough.
It really is. Previously, the industry relied on chain of thought, which is forcing the model to write out its logic step by step so a human could audit it. But if a model is deceptive, its chain of thought could just be a lie.
Oh, right, a cover story.
Exactly. The J-space essentially acts as an fMRI for artificial neural networks. If a model is secretly harboring malicious code or recognizing a biological threat, auditors can see the mathematical representation of those concepts activate before the model takes action.
Which is huge. And Anthropic is aggressively moving these highly interpretable models into enterprise deployment too. They just rolled out Claude Cowork to mobile and web.
Yeah, that allows you to delegate a task to Claude, close your laptop, and the agent will continue running scheduled operations in the background.
And the usage data they released is fascinating. 50% of Cowork usage is dedicated to what they term the work around the work.
Oh, I love that phrase.
It's so true, right? It's not the final creative product. It's the data imports, the spreadsheet reconciliation, and the status updates.
It's the structural scaffolding of modern knowledge work. And the scale of deployment is expanding into some really high-stakes environments. Joel Hron, the CTO at Thomson Reuters, confirmed they are evaluating models like Claude for fiduciary-grade legal work where hallucinations are just categorically unacceptable.
Right. But the deployment that truly demonstrates the current capability is in physical AI. I saw that UST is utilizing Claude to validate semiconductor chips before manufacturing even begins.
I have to ask, how does an LLM actually process physical hardware? A chip isn't a text document.
Right.
How is an AI validating physical silicon?
Well, because at the design stage, silicon is essentially code. LLMs process hardware description languages like Verilog and chip pinout matrices as complex relational graphs.
Oh, I see.
The model isn't looking at a physical object, it is tracing the logical dependencies of the circuit design. UST integrated Claude to ingest these massive schematics, trace the logic gates, and write the regression tests to ensure the hardware will function before a factory commits to a billion-dollar production run.
So it's analyzing physical logic through the medium of code.
Exactly.
And we saw a similar massive scale code operation in the public sector this week, too. The government of Alberta deployed Claude to scan 466 million lines of their legacy code to identify and patch cybersecurity vulnerabilities.
Which is just a monumental task. Right, this is a project initially scoped to take over 6 years. But the AI completed the scan, wrote the pull requests, validated them against unit tests, and secured the infrastructure in 20 hours.
Automating government infrastructure in a single day leads us directly into the raw economics of this intelligence explosion. Because Cursor, the AI code editor, launched Grok 4.5 this week, trained jointly with SpaceX AI.
Yes.
And it utilizes a mixture of experts, or MOE architecture, making it highly capable at deep knowledge work.
Okay, before we look at the financial data they released, let's clarify that architecture for a second. A mixture of experts model isn't just one monolithic brain processing every prompt, right?
Correct. And MOE architecture is fundamentally a router network. Instead of activating every single parameter for a basic query, the model contains specialized subnetworks, or experts. Yeah. So if you ask a complex Python coding question, the router analyzes the prompt and sends it exclusively to the subnetwork trained heavily on Python syntax and logic. This allows the model to have a massive total parameter count, giving it deep, specialized knowledge while keeping the inference cost incredibly cheap, because only a fraction of the network activates at any given time.
And that cheap, highly capable inference is driving some staggering financial outcomes. Cursor launched a CFO council to track the fiscal impact of their tools.
Right.
Bindu Reddy actually noted that Grok 4.5 is now outperforming Gemini. But the most jarring data point was that companies in the top quintile of token usage experienced 16.5% year-over-year revenue growth.
Yeah.
Meanwhile, the companies in the lowest quintile of AI usage saw only 5.1% growth.
That is an 11.4% spread in revenue growth purely correlated with token consumption. It's massive.
But let me push back and challenge the causality there for a second. Is this just a correlation artifact? Like, are successful, cash-rich companies simply buying more enterprise AI licenses because they can afford to? Or is the heavy token usage actually the engine driving that 16.5% growth?
It is a vital distinction to make for sure.
Yep.
But if we analyze the developer output metrics, the causality really points toward the AI. We're essentially watching a software-specific Jevons paradox play out in real time.
The classic economic paradox where increased efficiency leads to higher consumption rather than savings.
Exactly. When the steam engine made coal power wildly efficient, we didn't burn less coal to save money. We burned exponentially more coal because we built factories everywhere.
Right.
In the knowledge economy, as the cost of cognitive labor like writing code drops to near zero, demand for software approaches infinity. Companies aren't using AI to write their existing software cheaper. They are using AI to build entirely new product lines that were previously cost prohibitive.
That makes total sense.
And the developer metrics back this up. Cursor's data shows that the top P99 developers are producing 46 times more AI-assisted lines of code than the median user.
A 46x multiplier for power users. I mean, that kind of leverage is completely fracturing the traditional job market, which brings us to the major trend we're tracking this week, the code-based migration era and the resulting breakdown of tech hiring.
Yeah, that 46x multiplier makes legacy technical debt almost trivial. George Lee Orris at The Pragmatic Engineer detailed a massive case study on this just this week.
Right, about Bun.
Yes. Jared Sumner, the creator of the JavaScript runtime Bun, used Claude Fable to rewrite the entire Bun runtime from Zig to Rust.
And migrating a core runtime to a new language is notoriously one of the most painful, expensive, and risky operations an engineering team can undertake.
Oh, absolutely.
You're usually talking about a dedicated team of senior engineers grinding for 1 to 2 years.
But using AI orchestration, Jared Sumner completed the entire Rust rewrite in 11 days.
It's unbelievable. But going from a multi-year roadmap to an 11-day sprint creates a brutal catch-22 in the job market right now. You would assume software engineers are more valuable than ever because of this output, but the very tools making them 10x faster are making it impossible to actually get a job interview.
It's totally broken.
Hiring managers are entirely abandoning inbound applications. Their pipelines are just choked with thousands of perfectly generated AI slop resumes and cover letters.
And as we established at the top of the deep dive, the remote hiring process is being actively compromised. Security firms are tracking highly coordinated efforts, frequently attributed to North Korean state-sponsored hackers, utilizing AI to fake live video interviews.
Mechanically, how are they bypassing a live conversation, though?
They mask the compute latency. The pipeline requires routing the interviewer's voice through a speech-to-text model, feeding that text to an LLM to generate the coding answer, and then piping that answer through a text-to-speech model tied to a deepfake avatar.
It sounds like it would take several seconds.
It does. So to hide the seconds it takes to process all of that, the hackers introduce artificial network lag into the video call.
Oh, wow.
Yeah. The interviewer assumes it's just a bad internet connection, while the AI calculates the perfect technical response in the background. Because of this, companies are simply shutting the door and hiring exclusively through trusted personal networks.
Which means brilliant engineers without existing network connections are sending out resumes and just getting ghosted, completely blocked by the noise. The market has violently bifurcated. If you're an AI engineer or a forward-deployed engineer, someone who orchestrates these multi-agent systems, you can write your own ticket.
Well, the market is on fire for them.
But for a general software engineer relying on legacy coding loops, the technical bar to get an interview has skyrocketed, while compensation is completely flattening out. If one person can migrate a code base in 11 days, the enterprise simply doesn't need to hire the other 10 engineers.
It is a ruthless efficiency optimization. But that optimization leads us directly into our take of the week, which questions the long-term cognitive cost of this efficiency. Wharton professor Ethan Mollick published a very provocative critique, arguing that current AI agents like ChatGPT work or Claude code are entirely too software-brained to be useful for general knowledge work.
It's an interesting premise, because in software engineering, the final compiled code is the absolute single source of truth. The compiler either executes the code or it throws an error.
Right, exactly.
Therefore, AI agents are structurally optimized to sprint past the drafting phase and just deliver that final working outcome as fast as possible.
But Mollick argues that for strategists, analysts, and managers, the final PowerPoint deck or strategy memo is not the actual deliverable. The value is in the process, the exploration of alternatives, the wrestling with contradictory data, the failed hypotheses, and the learning loops. That is where the human builds a mental model of the business terrain.
Let me push back on this a bit because this feels almost a bit nostalgic for the sake of it. If an AI agent can ingest my company's financial data, analyze the market trends, and hand me a perfect, mathematically sound strategy presentation in 5 minutes, why should I care about the messy drafts? Did it just save me 3 days of agonizing over pivot tables?
Well, it saved you 3 days of formatting, sure, but it robbed you of the cognitive friction required to actually understand the strategy.
Right.
If the AI builds the mental model for you, you don't actually understand the nuances of the terrain. When the board asks a question that requires pivoting away from the slide deck, you won't know the answer because you didn't do the mental reps to discover why the other options were discarded.
That's a fair point.
You basically become a rubber stamper of AI outputs rather than a strategic thinker. Malik's critique forces us to ask, in our rush for pure efficiency, are we forcing all knowledge workers to behave like programmers, treating nuanced strategic thinking as if it's just code waiting to be compiled?
That is a phenomenal point. If you take away the learning loop, human understanding degrades. If you offload the friction, your strategic muscles simply atrophy. You get the output, but you lose the expertise. It's a vital reflection for our listeners to ponder as you integrate these multi-agent systems into your own workflows. Are you utilizing AI to eliminate the busy work, or are you using it to skip the cognitive friction that actually makes you valuable?
Striking that balance is really the defining challenge of the agentic era.
It definitely is. Well, as we wrap up this deep dive, let's distill the massive shifts we covered today into our one-sentence recaps. First, OpenAI's GPT 5.6 SOFL and ChatGPT work are shifting the frontier focus from raw, zero-shot intelligence to relentless agentic persistence and maximum performance per dollar.
Second, Meta's Muse Spark 1.1 proves that by utilizing reinforcement learning and test-time compute, open-weight models can organically learn to double-check and refine their own logic before outputting a response.
Third, Anthropic's mapping of the J-space proves that Claude utilizes a hidden internal workspace to silently reason about concepts like deception, while simultaneously deploying those capabilities in the real world to validate physical semiconductors and secure critical government infrastructure.
Fourth, Cursor's Grok 4.5 utilizes a highly efficient mixture of experts architecture, and their economic data confirms that heavy token usage correlates directly with massive double-digit revenue growth.
And finally, while AI orchestration allows a single developer to rewrite an entire codebase in 11 days, it has fractured the human job market, creating a chaotic ecosystem where AI-generated resumes and deepfaked applicants battle against exhausted hiring managers.
The velocity of change this week has just been truly staggering.
It certainly has.
Yeah.
To our listeners, if you found today's deep dive useful for cutting through the noise and understanding the mechanics behind the news, please leave us a rating and a comment on Spotify or Apple Podcasts. It really helps us continue bringing you the clearest signal in the industry.
And I want to leave you with one final provocative thought regarding that broken hiring market we talked about.
Okay, wait on us.
We discussed human hiring managers being overwhelmed by deep-faked AI applicants masking their latency with artificial network lag, right? Well, if an AI can flawlessly fake a live technical interview on behalf of a hacker today, how long until enterprise companies simply deploy AI HR agents to interview the AI candidate agents, leaving human judgment completely out of the loop?
Wow. An incredibly chilling yet highly probable timeline.
Yeah.
Thank you for joining us, and we will see you for our next deep dive.